Okay, I am going to show you today what you're going to do with the handout. So there are 4 pages of the handout, and today there will be some working. It's going to take the whole period. It's very easy though, very easy. Okay, so don't make it too difficult. It's really nothing more than just plotting points. Okay, it's really straightforward, just plotting points. Okay, so we have seen this thing called absolute value expression for some time now. We have seen them in equation. We have seen them in inequality, and now we're gonna start learning to make some graphs. Okay, so in case you have not seen a absolute value graph in the past, this is how it looks like. Let me go ahead and show you real quick. So y is equal to absolute value of x. Okay, so an absolute value graph, it's going to show up something like this. Okay, you have a little V shape right here, and we have a few features. Okay, we have a few features. You see the pointy part right at the origin right now. That's going to be called the vertex. Okay, that's called the vertex. And we will also talk about something called a range. Range is simply what we call the what is it called? The just the y values, the y values that's being covered by this the y values that's being covered by the function itself. Okay, like for this one, if you look at the whole V-shaped graph, which is strictly above the x-axis, then we say, hey, what's the domain here? Can you see what the domain here is? The domain here, it's going to be, well, again, the way we say it, it's going to be from small number to big number. I would say, oh, the domain here, it's going to be from 0 to infinity, because look at the y values, okay? The graph, it's going to cover all the positive y values. Okay, so that's why we'll call that the range. Okay, so we'll see more examples, and you can get more idea. So let's take a look at here. We'll talk about slope. We'll talk about slope. We'll talk about x-intercept, and usually it's really obvious. You can just look at the graph and you would get it easily. And you can work this as a group. Okay, you can work together. So it's just a little bit of a number crunching. So now when we talk about these function notations, it's really easy. It's really easy. So let me go ahead and show it to you here. Now, when we say x is -3, what it means is that for this particular function, this x will now be whatever that it's being stated. So now this is, let me work on this on the side. So when we say x is equal to -3, so we will go ahead and say, all right, so this is x equals to -3. So you practically replace every single x, all right? You replace every single x with the given value right here, -3. Okay, so that's it. That's notation. So we'll say, let's go ahead and replace this with -3. So it's just like, the last week or so, we would tell you what the x value is, and then you find out the y value. It's basically the same thing, all right? So you will replace the x with -3, and we say, hey, what is absolute value of -3? And you say, well, of course, that's 3, right? So then you put a 3 right there. And once you do that, you put a dot right here. Okay. Now, one thing that we know for sure about all of the graphs that you're going to produce is that they will all be V-shaped graphs. V-shape. Okay. V-shape. So Now, what about this? Now we say, oh yeah, f of -2. All the x's will now be replaced by -2. What would that be? Absolute value of -2. That would be just 2. Okay, so you go to the graph and you say, all right, -2 comma 2 right there. Okay, and you just keep going with the same procedure. Now, one thing I can help you is that the work that I showed here on the left, they are not required. So I'm going to make it gray. Okay, if you can simply see it, see how these x's will be replaced by these x values one by one, then you can say, all right, I've got -1 comma 1. That's my point. So I'm not sure if you also remember that some people would call this the y value as well. So they are at this point pretty synonymous with each other. So that's what you have. You can continue and say, oh, x is 0. What is f of 0? Okay, and we say f of 0 it's equal to absolute value of 0, which is 0. Okay, what is f of 1? F of 1, it's absolute value of 1. So 1. Then you keep going. So that's pretty easy. And then you will go ahead and plot the corresponding points, which is 0, 0 over here. Okay, 1 comma 1 right here, 2 comma 2, and then 3 comma 3 like this. And once you see the V shape, you can just go ahead and extend the line. All right, extend the line just like that. Okay, and then we have the graph. So now we're going to describe the graph and say, hey, where is the vertex? And we say, oh, the vertex is located at 0, 0. It's a point. So we will express this as a point. What about the slopes? Well, you have two lines, and if you count the squares, the slopes are, well, let's say a 1 and -1. We have two line segments. They have different slopes, so 1 and -1. What about the x-intercept? Does it touch the x-axis? We say, yeah, it touches the x-axis right here. So therefore, we'll say it is 0, comma 0, which happens to be the vertex. And now let me go again. Let me go ahead and explain what range is one more time. So you look at this graph. This is how we draw a graph, and we'll keep going right up. So when we talk about range, we are simply concerned about the y values that are covered by the graph. And you can see that the y values that's being covered by the graph, it's only on the positive side, nothing on the negative. So to describe this particular interval from small number to a big number, and also asking you, like, if we keep going up, what is the y value right here? Okay, well, that y value, it's going to be called infinity because you go all the way up, right? So we'll say, oh, so your interval for the y values that are being covered by the graph here, it's going to be from 0 to infinity. All right, and we said that we always use parentheses for infinity, remember? And do we include 0 here? Is 0 included? And we say, yeah, because you can see the solid point right here. That's included. So we will use a bracket for 0. Okay. Now I'll do a couple more examples for you. Okay. So that you have a better idea what to do. All right. So next one, we'll say, all right, now it's not just a simple absolute value of x. We have a little bit more, okay, added here. So we have absolute value of x plus 2. So let's think about this. All right. So here we go. X is -3. That means right here, boom, replaced by -3. So again, I'm going to work it on the side. So f of -3, it's equal to absolute value of -3 plus 2. Okay? So what is absolute value of -3? That would be 3, right? 3 plus 2, it's equal to 5. So at x equals to -3, y it's equal to 5. So you go to -3 right here. 1, 2, 3, 4, 5. So the point is right here. Okay. So you're going to repeat this same process for all the other numbers. So f of -2, it's equal to, again, you replace all the x's with -2. Absolute value of -2, it's 2. 2 plus 2, it's 4. So -2 comma 4 right there. Very lovely, very lovely. And then you have -1 into the x, right? So replace all the x's with 1, and then just carry out the rest of the procedure. So 1 plus 2, it's equal to 3. So we'll plot the point -1 comma 3 right here. And then you will go ahead and do f of 0. And you may use another piece of paper if you need it. What I hope is that you may need to write it out when you're working on this right now. But as you practice more by next page, and definitely on page 3, you can scribble something, you can take care of this mentally. That will be the ideal outcome. Okay, absolute value of 0 is 0. 0 plus 2 is 2. All right, and you keep going. You put in 1 over here. Okay, you can scribble like this. Okay, especially if you have just positive number, then it doesn't hurt, right? So 1 plus 2, it's 3. All right, and then you think about these x's being 2. 2 plus 2 is 4, right? And you start putting dots over here as well. 2 comma 4, and then what about the 3 right here? Absolute value of 3 is 3. 3 plus 2 is 5. So right here. So there you go. You have the absolute value function right here. Now make sure you extend the line. Okay, you will always extend the line so that you have a long enough line. Do not stop right here. All right, do not stop. You're gonna extend all the way, and it's a V-shaped graph. We know it's going to be a V-shaped graph, and we're just plotting values to make sure that we get it. So where's the vertex? The vertex is going to be at 0 comma 2. The slope, it's still 1 and -1. We don't have any x-intercept right here because the graph doesn't touch the x-intercept. So again, that's not much of a calculation going on except the table right here. All these blanks right here is just look at the graph. Just literally look at the graph, obtain the information, and be done with it. Okay. What about the range? And we say, well, the graph it's here. It does go up continuously, so we know it's going to go all the way to infinity. But what is the smallest y value that the graph covers? The smallest value that the graph covers. That would be a negative. No, not negative. Crazy. It's right here, right here. This is a 2, okay? And then we include a 2. So we'll say the range is going to be from 2 to infinity, okay? From 2 to infinity. So that would be the same procedure for the next 2. So in the next video, I'm going to go over the example on the next page, okay? The next page. So click the next video when you're done with the graph 3 and graph 4, okay?